Good night, everyone. It is 10 p.m. in Japan. I was speaking before I fall asleep. I'm Yuki Kanazawa. I am site reliability engineer at a company called Lansat. I joined my current company in 2013 as an infrastructure engineer. Since I'm SRE, my main job is infrastructure improvement, but I also do something programming for it, of course, PHP. Please me brief introduction to Lansat. Lansat is the first crowdsourcing service in Japan and a startup company founded in 2008. Globally, Upwork is probably the most famous crowdsourcing service. Elance and Odesk are older and more famous ones, but these two companies merged to form Upwork in 2015. In Japan, Lansat has become one of the most famous comprehensive crowdsourcing service. Lansat's main business is crowdsourcing, but it has also recently expanded into human resources and educational services. The main focus is on the Japanese market, but there may be possibility of global expansion in the future. Even though we are a startup, Lansat has been in business for more than 10 years. During that time, we have continuously made technological updates, and I will discuss how we have done so. Lansat is developed with CakePHP and has been running for more than 10 years while being upgraded. Now it runs on CakePHP 2.10, and I am trying jump up from CakePHP 2 to CakePHP 4. This is the server configuration diagram of Lansat. The production environment at Lansat is running on AWS. In this diagram, there is an admin server and a batch server in addition to the app server. And all of them were running on the same CakePHP 2 repository. Of this, we have split the repository for the admin and batch servers and developing them from scratch using CakePHP4. In 2022, we also migrated our production operations from EC2 to containers. We are now creating a new container for each release, which makes it easier to upgrade, especially for PHP. We recently completed an upgrade to PHP 8.1. Progress is 75% for the admin and 50% for the batch. These two projects, which are being rebuilt in CakePHP4, are applying the generation gap pattern. Let's get to the main theme. First, the generation gap pattern is explained. Generation gap pattern is a type of design pattern. It is that assumes automatic source code generation tools and is designed so that automatic generation can be repeated even after design changes. Automatic source code generation tools include those listed below. Most web application frameworks provide automatic source code generation. Among them, CakePHP's Bake provides a powerful automatic source code generation feature. Specifically design the following. Automatic source generator generates only superclass sources. The programmer creates only its subclasses. Instantiate only subclasses. Subclasses inherit, override, or add new methods to superclass methods. The auto generator does not change the interface used from the subclass. The automatic generation tool does not change the template method either. I will now explain how to apply this design in CakePHP. In CakePHP, there are opportunities to apply the generation gap pattern in the automatic generation of models. If we are implementing with CakePHP, at first, we will probably want to use Bake automatically generate the initial source code. When the source code for model is automatically generated, the sources are placed in the following directory respectively. By processing with implementation on the automatically generated source, the web application is completed. The success of this web application depends on the efforts and luck of the implementer. If they do not succeed and give up, they will not implement anymore and will not cause any problems. However, they will most likely implement additional features to make the service successful, or the service may be successful and the user may request additions. If such a situation arises, they will do additional implementation. Depends on the requirement, we may update the database. There will be situations where columns will be added. If the table column configuration changes, the model source will need to be updated. In that case, the source must be modified manually. This is because rerunning Bake will override the implemented source code and the implemented source will be lost. This is the problem. The generation gap pattern solves this problem. Based on this, I will explain how to apply the generation gap pattern in CakePHP. By the way, the update option was recently added to Bake. Perhaps this update may make the generation gap pattern unnecessary. This presentation will be on the subject of how we would have addressed this issue in the absence of this feature. Place the auto-generated classes in a directory dedicated to Bake. In this example, a directory named Baked is created directly under model, and the source of the superclass is generated it. The green part is the source generated as a superclass. For the first time only, inherited classes are also generated in the Diff in the default directory. The blue part is the inherited class, and the implementation is done here. The implementer makes an additional implementation in the inherited class. Then, if the service is successful, a DB update with table changes will be performed. Then, bake will reflect the result of the DB update. Only the green superclass will be updated at this time. This structure prevents the loss of implemented sources. And this is the generated gap pattern on CakePHP. To achieve such a generation gap pattern in CakePHP, the default bake must be modified. The first time, it is necessary to create a directory and inherited classes for bake. And for the second and subsequent times, it is necessary to have a mechanism to update only the bake dedicated directory. Lancers has created an original plugin that enables this bake mechanism, and I would like to introduce it. The plugin name is CakePHP Generation Gap Pattern Model Baker. It is registered on packages, so it can be installed from Composer. This plugin generates the source code with the structure of this presentation. On the left is the default bake behavior. And on the right is the plugin bake behavior. By specifying extended model as an argument, it is generated with generation gap pattern. I had planned to end this presentation here, but bake was updated while I was creating it. As mentioned earlier, the generation gap pattern may no longer be necessary. Since version 2.8, tables and entities can be updated non-destructively. It will hold user-defined functions, properties, and constants when a table or entity file already exists. Let's try new bake. On the my project, this is implementing project with generation gap pattern. This is superclass user table, and this is inherited class. And this is auto-generated only, and inherited classes. My implementation is on the inherited class. And let's try a new bake. Bake version is 2.8.81. And my plugin is disabled because the bake update option does not work properly. So I commented. First, let's override the model with normal bake without update option. So inherited class is this and implemented function. Oh, exchanges, not exchange.
Oh, your screen is frozen for everybody. Maybe you can stop it and reshare.
Yeah, sorry, I was on mute talking.
Can you see my screen?
We can, but it's kind of frozen and distorted.
Okay. Can you see my screen?
Yes.
Okay. Yeah. So I explain again. Let's try new bake on the my project. This is my project, and this project developed by generation gap pattern, and this is table, superclass table, and user table is only auto-generated, and inherit class user table is this is inherited classes, and my implementation is here. This is function, implemented function. And first, I try bake normal bake. So, model table, user table, override, and entity override. This is override generated sources, and my implementation may be lost. It's Diff. This is different. My implementation is lost. This is the normal bake behavior, and next Next, let's run with the updated option. My implementation, okay, is appeared. And with update option, model table override and the entity override. Okay. Overrides generated source. But my implementation may be moved below. Okay, it appears my implementation moved below. If it works correctly all the time, there will be no need to create the generation gap pattern. That's all. Thank you very much for your attention.